Hello everyone, today we will talk about the trapezoidal rule. Here are some important points I have to talk about. The first one, what is the trapezoidal rule? I will talk about the definition of this. The second one is how to use function graph to introduce this rule. The third one is the example of trapezoidal rule. The fourth one is the advantage of trapezoidal rule. And the fifth one is the limitation. This is the definition of trapezoidal rule. In mathematics and more specifically in numeric analysis, the trapezoidal rule is a technique for approximating the definite integral, like this below. The definite integral fx derivative x evaluates from a to b, and use this rule we can get that this formula approximately equals to delta x over 2. Multiply the long formula. And at this time, we should notice that delta x equals to b minus a over n, and xi equals to a plus I multiply delta x. We can see that in the graph. X in the interval a to b could be inserted n minus 1 points, and the x is divided into n parts by x0, x1, x2 to xn. The figure, which is made up by x equals to b, x equals to a, and y equals to 0, could be separated into trapezoidals with curves. If we connect xi, fxi, and xi plus 1, fxi plus 1, like the graph shows. And we know the area of the trapezoidal is h1 plus h2 multiply xi minus x2 over 2. And this graph could be similarly separated into lots of trapezoidals, and the area of all trapezoidals close to the real area of the graph. Try to imagine that we have the section a to b divided for infinite times, and every small section's length will be close to 0. In this situation, the limitation of the trapezoidal sum is the area of the figure. Now I will talk about the method to solve these questions. The first step is to separate. Insert n minus 1 points in the interval from a to b, and a equals to x0 and b equals to xn. Get n small sections like xi minus 1 to xi or xi to xi plus 1. Use delta xi equals to xi plus 1 minus xi as the length of number I section. Draw the vertical lines passing those points, and we can see some small trapezoidals with curves. The area we can record it as delta ai. Second step is that to get the similar value in section xi to xi plus 1, the area of this trapezoidal is fxi plus 1 multiply delta xi over 2, according to the function of the trapezoidal area. Delta a approximately equals to this as well. The third step is that to summary, add up n trapezoidals, and the area equals to sigma I equals to 1 and to n delta ai, and approximately equals to this long formula. The fourth step is that to get the limitation in order to get close to real area, make the length of every section shrink to infinite small. If the limitation of sigma of this form exists, we can see that this conclusion is correct. Now I will give you an example. Fx equals to 4x to the power of 3 plus 3x to the power of 2 minus 6x plus 9. And we have to evaluate the value of this form. There are some important points, as it is shown in the graph. The area of the region bounded by f between negative 1.5 and 1 is approximately the sum of the area of the 5 trapezoidals. 5 sub-intervals because fx more than 0, all of the 5 intervals are above x-axis. Make delta x equals to 0.5, we can see that the first area from negative 1.5 to negative 1 approximately equals to 6.3125, and the second area is about 6.5625. The third area is about 5.3125. The fourth area is about 4.0625. The fifth area is about 4.3125, and the summary of those areas is about 26.5625. That is to say, the area of this definite integral is equals to 26.5625, and we use the trapezoidal rule to calculate. We can see that they have the same result. Now we use antiderivative method to calculate again, and we can see that they are the same result. This rule has some advantages. The first advantage of it is it's easy to calculate because it's a very simple rule and it to calculate the data. The second one, it is sometimes applied in some special situation such as line x, because line x, if we use the antiderivative method to solve it, it seems complicated, so we have to use this trapezoidal rule to solve it. The third one is, at the beginning stage, it is more easy for students to have a direct sense of result of definite integral. That means it can give you a direct sense of it and help you understand it. However, trapezoidal rules still have some limitations. The biggest limitation of trapezoidal rule is that large errors because the calculation of this area is not accurate. We face some questions that needs accurate calculation. This method could not be able to fit for those situations. Another limitation is that the area sometimes could not be easily calculated when the interval gets bigger, especially when people dealing with some data that have irrational number, which is too complicated that they can only be dealt with computers. What's more, this method will create problems such as slowing our speed of working out these questions. That's all. Thank you for listening.